This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
This is Sam Taggart for SE Radio. I am here today with Bergh Johnsson and Deogun. Deogun is a frequent conference speaker on cybersecurity. He's worked on cybersecurity in a wide variety of domains and is currently the Chief Academy Officer for Omega Point in Sweden. Bergh Johnsson is a partner at Omega Point and also a frequent conference speaker. Along with another Dan Sawano, Dan and Daniel authored a book called Secure by Design. We've talked previously about security in many episodes, such as 584, Charles Weir on Ruthless Security for Busy Developers, 453, Aaron Reinhardt on Security Chaos Engineering, 418, Vladimir Korokov on Functional Programming in Enterprise Applications, and 405, Yevgeny Brickman on Infrastructure as Code Best Practices. Welcome, Dan and Daniel.
Hey, thanks, Sam.
Thank you so much.
Thanks for having us.
Thank you. Let's start by talking about your book. My main takeaway from the book was that instead of training engineers to be security professionals, it is easier to emphasize good design practices, and that those good design practices just so happen to address a lot of security concerns as well. Is that the intended takeaway?
Yeah, I would say the purpose when we wrote the book was that as engineers, as developers, you're so focused on delivering new features, keeping the timelines. You have a tech lead or some sort of project lead that's on your back all the time. So keeping your focus on security as well, that becomes a great burden. Or what do you say, Dan?
Yeah, I would say it captures 95% of the intended meaning. You get a lot of security from focusing on good design patterns, which, as Daniel alluded to, is easier for developers to just keep at the back of their head all the time than explicitly thinking about security. Whereas there is a rest 5% that you really should be aware of security practices and special procedures as well. So you can't ignore them. But definitely, I think you kept 95% of the intent in that assessment.
So in general, as a developer, you would then start writing secure software simply by applying good design practices and get that security, I wouldn't say for free, but for a lot cheaper than you would do otherwise.
So that brings me to a question. Is there some baseline level of generic security awareness training that you recommend for developers, or is your recommendation more just to let developers focus on good design?
I think there's to be able to have these kinds of ideas that Secure by Design is around, that you should use design patterns in a deliberate way to get improvement in security. You need to have a basic awareness of what things you are addressing. For example, there's a lot of practices to protect yourself against cross-site scripting or SQL injection, stuff like that. But if you don't know about SQL injection at all, you don't really know what good designs to look for. So familiarity with quite a breadth of security things, but you don't need that kind of like specialized knowledge to get a lot out of benefit from that knowledge.
Can you describe the traditional approach to security and some of the problems with it?
I would say one of the challenges with the traditional view is that you have to almost be an expert to understand what to do. And if you misconfigure something, it could be a framework, it could be a library or whatnot, you might miss something. And if you make that mistake, suddenly you're vulnerable or you allow something. And that's a big problem for many developers, that they don't feel educated enough on that topic in order to make those type of decisions.
Yeah. We often see that there's kind of like a gap traditionally between traditional development role and traditional security role, which is hurtful actually, because it makes developers shy away from security and say that, we have met really senior architects that say, I take responsibility for the uptime of the system. I take responsibility for the maintainability of the system, or I take responsibility for this and this and that. But when it comes to security, they go, security. No, I'm not a security. There are specialists that will take care of that, which does not really help at all.
And the fact that you have that mindset points to an organization where you have us and them, that security is somebody else's problem. It's not really your thing. But in reality, security is a concern. You need to design your software in a way that it's secure in every aspect, so to say.
And we have seen a similar play out before security. If we look at the early days of Agile, with this gulf between developers, that is coders, programmers, and testers, where testing was a very separate activity. And the collaboration between developers and testers were not always hard, but perhaps even like antagonistic. And it didn't help either camp. And throughout a few years, we have learned to include coding and testing into the same cycle. And I think we see the same kind of progress now, that security has been a very separate field, but now security is embraced within coding and testing as a part of, as Daniel said, one of many concerns, and a really important concern, but none that should be treated separately.
Writing secure software today is more of an hygiene, I would say. It is an expectancy nowadays of almost any client you interact with. They expect the software to be secure. I mean, if you design something that's insecure, it's not going to pass as good software. So having the skill to apply the certain patterns, have the mindset and so forth, that becomes something that everybody needs to do now. And it's so important because of that.
So your comment on Agile and developers and testers, before you came up with that, I was thinking of the DevOps idea of combining developers and operations, which is also very similar. So there seems to be a theme there.
Definitely. I see that these are three very consecutive steps. First, developers embracing testing and testers getting to get a dev test culture. And then we've got the DevOps culture, and now we've got the security. So we're rolling more and more roles into this fruitful collaboration.
So do you still see separate roles for security practitioners as well? Is it about combining development and security together, or is it about both overlapping a little bit? How does that work?
I would say that you can compare this to a physician, right? I mean, you have experts, those that are really good at doing surgery or something. And then you have the common practitioner that sort of has a broad understanding. Most developers will be those that have a broad understanding, whereas you will still have experts in certain areas, right? I mean, it could be an expert in authentication, authorization, login, flows, stuff like that, right? Whereas some others might be experts in cryptology and stuff like that.
And if we jump the fence a little bit and put ourselves on the other side and ask the dual question to the security professionals, they say that, of course, we have got experts that are like really good offensive security testers that can try to get into your systems. But those experts become a lot better if they know a little bit of coding, or if they know a little bit about infrastructure or sysadmin or whatever. So I think we're seeing the same thing on the both side of the fence, that we will both retain our deep professional knowledge and expertise, but we will start to learn a little bit more about each other's in the cooperation. We'll get a lot better.
The book specifically talks about domain-driven design. I realize that's a very large topic with a lot of books written about it, but can you briefly describe the main ideas behind domain-driven design, the ones that at least apply to security?
Well, if we pick out the part that we think give us the most leverage, it is the message of domain-driven design that a conceptual idea of what you are building is really essential. An application or system is not just a lot of code that happens to work. It's kind of like encapsulate and encode a certain set of ideas and how they work together. So if you work on a finance system, you should know what is an account in this kind of context, as opposed from a transaction, which is something else. And they might, in different solutions, get together and have a little bit different meanings and different boundaries between them. But for this precise application we're building, we need to have a sharp understanding of what we mean with the different things. And that kind of deep understanding, which eliminates a lot of misconceptions and thus bugs, is what we built the security upon.
As you say there, Dan, the specificity of domain-driven design and knowing exactly what you need is what you can also use from a security aspect. One of the most common mistakes that are done is that you use two, generic or broad definitions of your data types in your software. So if you instead choose something that's very specific, then you can narrow the input to only match that definition. And then it becomes very difficult to inject something that violates that contract.
For example, if you're inputting an address, a zip code throughout the world might look almost in a conceivable format. But if you're just writing a software for France or for US or for some other limited domain, well, then you can narrow it down very, very harshly and get a tight definition of it.
Which makes injection attacks a bit more difficult to succeed.
Yes, there are several different directions we could go with this. You hit on several things that I want to talk about. The first thing I think that's worth talking about is domain language, because I think that goes to your specificity part. I remember working on a system where we had both order numbers and order IDs, and
that sounds fun.
Trying to remember which one was which and when to use which one was quite difficult, and we didn't really have a good dictionary of all the terms. So on a project, would you have like a domain dictionary that says these are what each thing represents?
I guess a dictionary, but what you would have, I guess, is a model, right? I mean, you have a conceptual model where your terms are defined, so to say, and the relationship between these terms. So that is what you should have, and we encourage everyone to define their ubiquitous language, as we talk in domain-driven design, right? To have one definition of the word and no synonyms and so forth. And that helps you to understand exactly what you need to fulfill for a certain concept in your domain. So in that sense, we have a dictionary, but it's expressed mostly like a model, I would say.
I would usually say that the dictionary is an excellent starting point for building a model. If you haven't got a dictionary, you should definitely start there and collect not all of the words that you use, but ensure to really well define some 15 or 20 that are real important terms. But as Daniel said, a language does not stop with the dictionary. It's also how do you construct the sentence, like what verbs and nouns go well together. Do you say that you register an order, or do you say that you put a purchase request, or do you say that you get a warrant form refill formulation or whatever? So watching out to see that have we got a lot of synonyms that there might not be precisely synonyms, and then in that case try to prune your language. You also get the idiomatic, what kind of phrasings go well together. And I think there's a lot to do with that you really need to speak that language out in the open, because then you'll catch yourself when you start drifting off that terminology and start using other words. That's a sign that here you got something that you need to specify a little bit better, because sooner or later you'll have to write it in code. And if you can't speak it clearly, you're in a worse position when it comes to coding. So yes, the dictionary is a starting point, but it's more about like books and literatures and how you express yourself in sentences.
I would also like to add that having your language shouldn't just be written down in a model or as a dictionary. It should also be reflected in your requirements, in your tests, and so forth, and in your code.
In your code, in your UX, the GUI.
So it is truly a ubiquitous language that you have created for your context where you operate.
Do you have any specific examples you've seen where miscommunication contributed to a security issue?
So you see it this way. You have a shopping cart, and in that shopping cart, you can add items or products, books perhaps.
Like 4 copies of Secure by Design.
Yeah. So 4 copies of Secure by Design, we say you have a quantity of 4, right?
So quantity is just an integer.
Yeah. The problem now is that if you have defined quantity as an integer, what you automatically accept in your software is all the capabilities of an integer. It can be added, it can be negative, and it can be extremely big, right? But from a business perspective, I assume you won't accept a negative quantity of books or a billion quantity of books, right? I mean, it doesn't make sense from the business perspective. But from the software perspective, that works since you used an integer.
And we've seen, this is really, there have been some really public bugs around this, where a negative amount multiplied by a positive price ends up as a negative contribution to the total sum. basically giving a discount. And this has been both in public domains, and we've seen it over and over and over again in our assessments where we've looked into customers and clients and worked with them. So you mean that I can create myself a discount by just adding -10 of order number, blah, blah, blah? Oh, that was not intended.
It is a discount feature, I would say, but it's probably not what the business would like. The interesting part, if you analyze this from a why does this happen, and usually it is developers' tendency to fall back on language primitives, language primitive types that you have. It either be a string, an integer, a float, or something like that. So they use that to represent a very specific concept in your business domain, but you use a generic concept to do that specific work. So string is also very common, that you accept a string, but you expected it to be an order number or what you mentioned before.
Now we're talking about just a range of sensible quantities, like from 1 or 0 up to 200 something or whatever it is. But it might also be the operations you can do on them. For example, we have had a client where let's obfuscate this a little bit to protect them. They had bus numbers. And at one point, there was an addition where one bus number was added to another bus number. And of course, that was not the intent. It was two other things, but someone had just mistaken two parameters for each other and ended up adding two bus numbers, coming up with something that looked like a bus number, but in the end made no sense at all and led to very strange behavior a few steps down the line. Also something that is preventable. You shouldn't be able to add two bus numbers to each other.
Yeah, I think the other place I've seen this is in something that maybe takes in two integers, but they represent two different things, and it's very easy to swap them if you're not careful.
Yes.
And especially in like a strictly typed language, if you swap them, then hopefully the compiler would catch that and break that if they were different types.
Like longitude and latitude just happened because which is long and which is lat. No one ever remembers that. There's also some more intricate stuff, like we were talking about some people in the online gambling industry, where they hand out money, like for free spins and stuff like that. And that is represented as dollars. But then people are very good at finding ways of registering something, get an amount of dollars free, and then withdraw them. So often they end up adding a lot of very strange business rules about what dollars you can withdraw after having this or that much gambling. And at one place, which we discussed with, they were actually doing explicit modeling of that. So they didn't have money. They had withdrawable money, they had deposit money, they had free spin money, and then they had rules for how to convert them to each other. So there's a good example where they actively had made a modeling decision to separate the different things.
I think it all comes down to if you are careful and start modeling your concepts and add, specific rules to it, then it becomes much, much harder to inject something that violates that. Like we see for every injection attack, that you inject something that the software didn't expect, right? So you can access the database and it behaves in a way you didn't anticipate and so forth, right? So yeah, be specific. That's our rule.
Either inject or to confuse the state.
Yeah.
That you end up in a state that was not anticipated and not desired, but enabled the user to do stuff that they shouldn't be able to do.
We've been talking around the idea of domain objects, which I don't think we actually specified. So in domain-driven design, this is idea of domain objects. You want to just say what that is?
So a domain object is most likely a concept that's native in that particular domain, right? I mean, if you talk about hospitality, then of course the room number is very common. If you're at the hotel and say, hey, put this on my room and things like that, that's a concept that needs to be expressed in that domain. So a domain object is something that's very familiar in that context.
I think it might be valuable also to point out that we in modeling often see these domain objects coming out in two main flavors. Modeling wise, the most usual that people tend to be familiar with from object orientation, basic 101 at universities and stuff like that are, of course, the entities. It's something that concept that models something which has got a lifespan and an identity that can be changed. So a stay at an hotel is something that might be prolonged. It might have a tab associated with it, which can grow. A person might be something that who can change their names and grow older or change their relationships and states in different ways. The other big modeling tool is, of course, the value object, which models a specific aspect of something, like a color red, or the number 4, or the duration of 24 hours. So it's a little bit more like writing something down on a piece of paper, and then you can be able to share it, but you will not change it. A duration of 24 hours cannot be 25 hours, because then it's another duration. So those two tools are very fruitful to keep apart.
So I want to make sure I understand correctly. When you're talking about value objects, generally they are immutable. Would that be a correct term to use?
Absolutely. A value object that is not immutable would be a very strange thing.
The next questions I have are around validations, but something occurred to me while you were talking, Daniel, about room numbers and, I want to charge something to my room. There seems to me there actually are two validations there. One is that it's actually a valid room number, but the other one is that there's actually somebody staying in that room.
Yes,
yeah.
Exactly.
And so in the book, y'all make a very strong point about the order in which you validate stuff and how that contributes to security. Can you talk a little bit about that?
Yeah. So the general principle here is that if you look at the relationship between an attacker and the attackee, I guess, then you want the relationship to be asymmetric in the sense that it should be really expensive for the attacker to craft the malicious input, and it should be really cheap for the recipient, the server, right? So we should be able to reject something quickly and at low cost. So because of that, we have just created what we call an order of validation. Basically, it's a 5-step order where we do the cheapest operations first. And, the first operation to check, that would, I guess, be origin. Does this come from a valid place? It could be that it does come from something that you trust, or that it has correct token or something like that, that it actually comes from a valid origin. It's okay to have data from that point. The second thing to check would be size or length, stuff like that. That would be constant execution time. Basically, very cheap to validate, is this room number indeed of proper length?
And it might be just roughly, like order of magnitude. If we expect something of 100 bytes, check that it's no more than 1,000 bytes.
So that means that what you have successfully done, simply by doing that, you have limit input vectors to meet that requirement. They can't be larger than your limit. They can't be longer than if it is a string, can't be more characters that you expect, or it can't be bigger in size if it is kilobytes or bytes or something. The second thing that you do, if it fits that criteria, you have to invest a little bit more. So in this case, we want to see that, does this input contain the proper characters? We don't care about the order. We care about it is the valid characters. And in a room number, it might be just letters. It could be a specific subset of letters. You can say that, a room number could either start with A or B, but no other character. And then there's going to be 4 digits. So you would know that, it can contain A or B, or the digits 0 to 9. That's it. So you don't care which order it is, but you say this input data does indeed contain the proper characters.
But what we do at that point is that we actually open up the package and look inside it. And that's why the first two, origin and size, are so powerful, because you can throw away a lot of attacks without even looking on the inside.
So the idea here is that we have to invest a little bit. Like Dan said, we have to open up the package. We have to look at the content. And if the characters match, then we say, the likelihood now that it is indeed a room number is quite high. But there is a chance that somebody injected something that it contains only A or B at the end or in the middle, or only characters. So we need to make sure that the order of the characters are also indeed correct. And in that sense, we would have to parse the data.
Like we could have a JSON, but we need to check that it's a well-formed JSON and that it's not incredibly deep.
Yeah. So doing that, we will then, of course, send that data to could be a regular expression engine, checking that. And the reason for why we're doing this so late in the order of validation is because the regexp engine, the backtracking algorithm that's used in there, is susceptible to bad input that could sort of halt your system.
And that is, of course, goes for a JSON parser and XML parser as well. Classical things you try to attack if you want to DDoS someone.
So basically, we move up the ladder of both complexity and cost from a recipient's point of view. And if it passes all that, then we can say, yes, this is indeed a true room number in this case. And we can then instantiate a domain object for that.
And then we end up at the fifth step, which I think you alluded to in the question, like touched on, which is, now that we've got this input, does it make sense in the system at this point of time? And to continue Daniel's explanation of what valuable resources we protect, then what we're protecting here is, of course, the database. Because to check whether something makes sense at this point of time, we probably have to fetch some data from the database, which is a pretty expensive operation.
So this fifth step is actually something we call the semantic validation, or it's a semantical check. And the best way to explain that is if you go back to your order object that you talked about before, an order object would probably have a method add or something to it. So you can add your products to your order. But of course, you can't add things after a certain time. Like, for instance, after you have paid the order, you shouldn't be allowed to add new products to the order. And because of that, you need to make sure that the add method is protected in the sense of, does it make sense to add something at this point of time? So usually, many developers tend to forget that. What they do is that they simply don't call the add method. That's how they protect against illegal adds, which is poor.
And we must say this 5-rung ladder of input validation, to us, it's a very central thing that then we build a lot on top of, like our designs of domain primitives is, of course, on top of that ladder. When we talk about consistency of state and state evolution, it's, of course, hung on this ladder as well. And just to pay credit where credit is due, we have to make a shout out to security researcher Dr. John Wilander, who was, to our knowledge, the one who phrased this specific ladder. Unfortunately, he hasn't published it into any peer-reviewed paper. Otherwise, we could have pointed to, and it would have been worth a paper of its own. But he's just mentioned it in conference presentation and here in his writing on a blog and stuff like that. But we really take it to heart and say this is a design principle that makes sense from a developer's perspective, but adds a lot of security, especially when you combine it with other patterns.
We will touch on some of those other patterns in a second, but before we leave the validation, how does the idea of allow lists versus block lists play into this discussion?
Once again, I would say you can compare it to being specific or generic in a sense. By doing allow listing, you're very specific. You're saying only these are allowed to enter. Whereas the blacklisting or disallow list, that would be, the opposite. It's much harder. It becomes easier to inject something or pass that type of guard if you go that route.
And you can see these 5 checks on the 5-rung ladder to be 5 consecutive allow lists. One allow list checking for allowed origins, like you have to have a claim in your token, or you have to have an API key, or you must come from a well-known IP address or whatever. Second one, you have to have an allowed size. Third one, you have to allowed characters, etc., etc., etc.
I remember reading a book called The Bug Bounty Hunter's Guide or something similar, and it was very eye-opening because it showed, here's how a developer might normally filter this thing, and then it was immediately like, here's how you get around it. And there was another, if they thought of this, then here's another way around it. And it just seems like a lot of that was based on this idea of like blocking specific things as opposed to like that whole specific general.
I think that's the blocking idea. And there's another idea that I've seen come in play in many places. It's where developers try to be helpful and fix input that is coming in and seems a little bit broken. Like, oh, there was not end of line at the end of this post. It was a null character. So then I help the input by replacing that null character with a line feed or whatever. It might be replacing or taking away quotes or double quotes or stuff like that. And then you often create a very intricate machine that you do not know all the effects of. And that is what the attacker is looking for. Look here, if I'm sending in this kind of stuff, they helpfully rewrite that into some other format. I wonder what I can do with that.
I'm curious, what role does input or unit testing play with all of this input validation?
So your unit tests are, of course, your intention is to see that the behavior is correct. But I would say from a security perspective, you can write unit tests that are more of a, let's call them a negative characteristic. You basically can test the boundaries that you have defined, right? I mean, if it is a length boundary, character types, and so forth. So you can see that you are truly rejecting things that are outside of your boundary. But what you can also write tests for is to sort of make sure that you reject things at a very cheap cost. Like, for instance, if you were expecting a zip code, and obviously that, it's a very limited set of characters or numbers. But if you write a test that tries to input a million characters, and if you have done it incorrect, your regex validation might halt. So even if you know that that million characters isn't a zip code, you should have rejected it immediately. So simply by adding those checks, you can very easily check that your code meets those criteria using unit tests. So,
apart from that, I would also like to add on the consistent usage of input validation. Because if you got a large system where you got a lot of order identities, order numbers, whatever the difference is, then you need to ensure that you add that small if statement with a regexp on every single input field. And if you forget to do it in a few places, or they become inconsistent in a few places, then you got vague inconsistencies that a security attacker might find interesting. Whereas if you drop that into something that is a unit testable unit, a domain primitive, a value object capturing the essence of the order number, and you have the unit test of that, then you automatically get that validation check in all the places where that domain object is used. So if you consistently use order number domain primitive in all the input fields, then you get the same enforced and the same input validation in all the places. So this is why I think domain modeling and using design patterns, it's kind of like comes natural, and programmer thinks it's nice, good looking code. So you get that draw to write good code and actually piggyback security on back of that drive.
I just want to reinforce what you said, because it was a very big point in the book too. Instead of passing around the primitives of the language, strings, numbers, you pass around the domain objects, and you put the validation check, which is a very specific things that you're checking in correct order, in the constructor for the object. And therefore, if it's in that constructor, then everywhere that you're constructing that object, you are making sure that that input is validated. And then everywhere you're using it, you're only using objects that can only be valid because you can only instantiate them through the constructor. Is that kind of the general idea?
Indeed. If you've got an order number in your hand, you know that it has passed through that validation check. It's a little bit like you have wrapped it and put a sealed stamp of approval on it.
This is as opposed to checking it at every single method every time you want to use it, which would get very...
Exactly.
Have anyone ever, deep down in a system, seen a small if statement saying, if order number matches and then a regexp? And you look at it and say, what the flying? We are deep down in the system. This should have been input validated like a gazillion times before. And then you start backtracking that code and you realize that it has actually passed through that specific pattern matching like 5 or 6 times already. But deep down there in the system, the program was still not confident to say that this string actually has got the right format.
The immediate next question that raises is, were all those regexes the same?
Exactly.
Most probably not. Subtle differences.
So I would say that what we touch upon right now also is the complexity of software. If you choose a design that we sort of encourage, like what we have called the domain primitive, with this validation and immutability of objects, and like a building pattern or a block that you can use wherever it's defined, then you reduce complexity. You don't have to have those double checks. You don't have to have all these regex everywhere and so forth, which reduces overall complexity. And by reducing all over complexity, you also decrease the risk of failure, which in turn reduces the risk of having a security vulnerability. So it sort of all goes hand in hand. By using code constructs that help you design better code, simpler solutions, so to say, you also reduce the risk of error. And makes it better and more secure.
Let's talk a little more about failure. That wasn't exactly in my list, but I remember talking about that in the book. There were some very specific points about like how to fail well. Was there a concept of bulwarks or something? Like the different compartments in a boat? Was there some? Do I remember that correctly?
Right.
Yeah.
Right. So if you look at it from an architectural perspective, one very common mistake is that you have cascading failures, right? So using proper bulkheading is a very good design pattern for you that allow you to limit the blast radius to a certain area of your design, and making sure that it doesn't propagate to your other areas, because then an attacker can simply attack the weak spot in your architecture. And then after a while, the problem propagates to the next one, and next one, and next one. So using good design to make sure that your bulkheading is good, then you protect yourself against that type of availability errors.
So one example of bulkheading could be to compartmentalize different customer regions into different databases that are sharded. It could be that you do not put everything into the same database instance, all of it. Because if one of the services crash because of the database, then all the services crash depending on the database. It's like having a big microservice architecture standing on the same tray. If the trays tip over, you've still got a single point of failure. So I think this bulkheading idea is very potent. It can be reused both in the infrastructure and in the constructions of the code, and also in the modeling.
That reminds me of the idea of an attacker breaking into a network and then moving laterally. Very similar idea. They find the one weak point, and then that happens to be connected to another point, and there's a gateway there, and then they just spread.
And this is basically what the new zero trust, I am not going to say fad, because that would something, but the attention to zero trust architectures is very much about not having parameter security, but having security in depth. What we often like to talk about is not only in depth, but having interlocking practices and interlocking patterns that grow stronger together than just practice one of them on its own.
Speaking of other patterns, one that I think struck me, because I had not really thought about it a whole lot, was the idea of logging and being very careful about how and what you log. And from a developer's point of view, not thinking about security, I always want to log as much information as possible because I want to be able to debug the issue. But there are very serious issues with that. Can you talk about that a little bit?
There's so many different types of attacks. And one of them would be like a second order attack. And the easiest way to explain that in terms of logging is that the attacker injects an attack vector that isn't really targeting your primary system.
So Daniel is sending it to me, but it's not really hurting me.
Exactly. And that attack vector is logged. So the log data then is interpreted by someone with, I guess, they're using a tool that's perhaps web-based or something, and there's a weakness in that tool. So that attack vector is for that tool, meaning that you use your system as like a jump host in order to attack that other system. Because of this, logging and our tendency as developers wanting to help all the time, right? We want to log so much so we can really help you in debugging things, can be a bit risky from the security perspective, right? So instead, we should log things that would describe the problem, right? Saying, I got an invalid input, it was too long or too big or something like that.
Without reproducing the actual input. would be one of the keys there.
Exactly. Yeah. And if you really, really need to get your hands on that input, well, then you have to reach out to whoever sent you that input, right? Then you can probably figure it out.
So, for example, why should you log input ad verbatim? Instead of tracking who sent you that what, then ask them, why did you send this?
I can think of an interesting reason to do that, though, and that's not from a developer's perspective, from a security researcher's perspective, right? If I'm the security engineer for the team and somebody sends me a thing and I get a thing that says, oh, it was invalid input, I am very interested in, well, what was that input? Because I want to know what tripped what they were trying to do, but I don't know how to do that.
We do acknowledge that situation and say that, of course, you can sometimes track things, but then you should put them in a separate database. It should be stamped with biohazard. You're only allowed to open this while wearing gloves, breathing protection. You have to have your certification to do it. No, but basically saying that this is dangerous stuff. This is potentially attack vectors that's in there. I think what we think is a very valuable way of thinking of it alludes to that developers often think about logging as debugging. But if you look at a running system, well, debugging is valuable. But what we really want logging for is operational insight. So it's really to help, what would we log to get insight into what the system is actually doing while running in production. You should be able to look at the system and say, oh, it's doing this. It's going well. And then you should capture interesting things. For example, it could be extremely interesting to sample those attack strings, put them in a really, really well-protected place. It might be interesting to look how much just rate of 200s versus 400s. So we need to do some kind of logging or metric around that. But that's not really the same thing as debugging. And we think that's a really important distinction between those two.
I would like to add also that another thing that many forget when we talk about logging and how you set it up in your system and so forth is that you tend not to limit the privileges for your log writing process. It's usually you only write data to your logs, but from a privilege perspective, you can still read data. So you forget the least privilege principle here. What you should do in this case, you should limit so your system can only write data to your logs, whereas a human or somebody that processes your logs can only read them. They can never write to them. By doing that type of separation, you create an extra security layer, so to say.
And we do see a movement here. Over recent years, people have gone more and more towards having centralized logging systems where you gather the logs somewhere instead of having them on one log file for each node of the server. And then you got a real correlation nightmare if you want to understand what's going on. So this is also something that is secure by design, through design. Those centralized loggings were mostly made to make life easier for sysadmin, for observability, etc. But they also have very interesting security side effects. So, which is, I think, a really nice example of something that has that kind of characteristics to secure by design, a design that makes things more secure. But we're stepping away from the earliest years of secure by design, which was domain-driven security, domain-driven design driving security. And then we reiterate that idea of having some kind of design that gives a security benefit, but in other fields.
Yeah. Well, I imagine the logging, the separation of reading and writing, that also helps with things like attackers getting in, deleting logs, and or like auditing and people manipulating logs to make things look better or whatever their agenda might be.
Exactly. And you get that sort of, what should we call it, security benefit by free. Even though you didn't think of it that way, you said, all right, well, let's just make sure that we can only write here. Then you have protected yourself against that type of action, so to say.
Taking that one step further, of course, you can also split your log into different places depending on the different purposes. For example, you want to have some kind of metrics log just to keep track of the performance of your running system. You might have some other kind of log for sysadmin maintenance. You might have a third log, which is for auditability. When the auditors come in and say, we want to have a look at that, we can see what's happened in your systems the last 7 years. And by doing what Daniel said, you can get that separations. So you can treat each of those log syncs for different purposes, separate.
You can also make your CFO very happy, because then, of course, you can have a much cheaper solution for your metrics compared to your audit log, right? That you need to maintain for years, whereas the metrics can go away tomorrow, right? I mean, it doesn't really matter. So that also comes from using that type of design.
But we think that log systems are so interesting and have so many concerns in and of themselves that we think that developers spontaneously don't take them serious enough. To a lot of developers, the log is just a file on your log system, but it's actually a subsystem of its own, which has own characteristics and runtime environments and financial implications and compliance implications. So we think it's really worth to spell that out and make the logging a first-order citizen subsystem. And it merits an API of its own. It needs a management of its own, etc.
Have you found that the recent log4j brought logging to more people's attention, at least in the C-suite, perhaps?
Well, guilty as charged, me personally, definitely.
I'm quite surprised when I talk to many people around that time. Many treated, log4j as console output almost, right? I mean, like if I input something, I expect that something to be output, and didn't see log4j as I would say, a library or a thing that was its own system.
It was a handy way to write to the log file.
Yeah, exactly. It was just a bridge to that. And they expected data to be output exact the same way as you input. I think that sort of at least put logging on the agenda.
Yeah.
Yeah.
I would say.
To be honest, we actually had a few presentations at conferences thereafter under titles like What Log4j Debacle Taught Us About Secure by Design and stuff like that.
There is one more topic I want to talk about briefly, and that is the 3 R's that feature in your book. Can you talk about that a little bit?
Sure. The 3 R's stand for rotate, repave, and repair. Dan, so what's your favorite R here?
I think we just briefly should just do the same thing and say, where is this design? Where does it come from? And where does it end up security-wise? So basically, this takes springboard off work in the reliability field for cloud. For example, the 12-factor manifesto, the rugged manifesto, etc. And it's a realm of designs that make things easier for you to survive in a cloud environment, but also comes with interesting security benefits. So the 3 R's. My favorite, I would say, is the one that is strangely named repave, but which I understand as replace, and is a routine of replacing your running instances in a structured and scheduled manner. For example, if you have a cluster of 5 nodes, then you spin up a new one, commission a new one, and then decommission another one just because it's an hour old, not because it's broken or something like that. So you constantly replace everything that you got on your cluster with fresh instances.
From a security aspect, what that means is that if you're, as an attacker, able to install something on those nodes, then you have to reinstall every time a new image is commissioned into your cluster. And then you might say, oh, well, that shouldn't be too bad for an attacker. They could probably script this or, keep installing their stuff on those nodes. But what that also then creates is traffic on your network, right? I mean, it increases the chances of detecting this type of activity. So that's only 1 R. By say, basically, let's in a random fashion, we could repave our cluster with, our images, for instance, if that's the case.
And the kind of threat actors that we want to make life difficult for is not the script kiddies that do drive-by hacking, because they're not that dangerous. those that we want to shield off in this kind of schemes, of course, the kind of persistent threat actors that do advanced persistent threats, because they got patience and they got resources and they install something and they use that as a sniffer. And by doing this kind of routine that Daniel talks about, they get lost. Or everything they've installed is just get lost and they need to reinstall instead. And then they increase the chances of getting detected.
Another R is, of course, rotation. And that's rotation of secrets, for instance. By designing your software to get your secrets from your environment, like a key vault or some other system that contains your secret, you could design it so that the secret is rotated on a random schedule. You can be really offensive if you want to. You can go by changing secrets after each call, I guess. That would be crazy. But in theory, you can have a very, very aggressive rotation scheme.
I think this becomes a little bit clearer if you see the anti-pattern that we are trying to antagonize against.
Right.
Daniel, what is the record holder we've seen of people having the same production database?
I think at least the record I think you're referring to is one client. Well, they hadn't changed their password in production for the past 18 years. The downside was that they also used the same password in their other environments as well, because it was much easier.
My immediate question is how many employees left during 18 years who still knew that password 18 years ago?
They were well aware that it was too many.
Yeah.
And I think there's something really interesting because that talks indirectly to what we are talking about, that the reason for not changing it for 18 years is it was too complicated to be able to get around that. You would basically need to have all the developers and all the operations people in the house at the same time. You had to tear down all the system, recompile everything from scratch, and get it up and running again. So the application design was putting a stop to doing rotation of passwords. And that is what Secure by Design, of course, is about, that we should make designs that make the systems operationable, so that it's possible to do these kind of things.
So I would say that if you have designed the software that you either, you hard code your secrets in your code, or that you supply them at deploy time, perhaps, that could also be the case, then you create a mess that all your dependent system on that secret needs to be either redeployed or recompiled, rebuilt, which makes it very difficult for someone to decide that, we should change this password now, or we should, rotate this. Instead, if you design your software such a way that you fetch the secret upon need, then you can simply rotate it in between those fetches, and also create a resilience retry mechanism against the resource that you're trying to access, and make sure that, if my key or whatever I have doesn't work anymore, I need to go and fetch a new one. And that sort of emulates the problem of a very flaky network or something like that, right? Or service.
I think it's interesting to see that this is also an instance where a lot of interlocking designs together give a very strong security benefit. Because under the hood for this to work, you have got the designs of making your configuration or configuration parameters external, which in its turn make it possible to make immutable builds, where you actually have the same build artifact in the test environments and in production environments and in multiple instances of the production environments, which also gives a lot of other security benefits. But it's all these design together that makes it possible to have this kind of light-handed, possible to change database production password without even having downtime.
So we need to wrap up here, but I do have one last question I wanted to talk to. And actually, you kind of changed my thinking about it. I was going to make the statement that it seems that security is more of a cultural than a technical problem, but I think what we just talked about hits on the fact that sometimes there are technical barriers to changing the culture. And I'm curious to get your thoughts on that as a last statement.
Well, actually, first, I want to address for the audience here, we actually just covered 2 R's. So I want to say the third R. That's actually very important. And that's the repair R. And basically what that means is that you can patch you rebuild your software, your images, upgrade them to the latest versions of your dependencies and whatnot, and then you can deploy it in your normal cycle of repavement. But then let's try to address Sam's question here.
To start with, I think there's a lot of merit to your original point that there's a lot of culture going on, even if that culture is technical. I think that is worth pointing out. There will be a lot of technical work, but for that technical work to be fruitful, you need to have a no blame, high cooperation, psychological safety culture. Because if you haven't got that and someone says that, I think our application design does not really make it easy to change passwords in runtime, then it might be perceived as you trying to wake criticism against the chief architect, and that chief architect might get etc., and things get sour. And this has also been studied in research, that organizations that are able to promote a high trust environment where you can feel your concerns and get them listened to and have an open discussion do display a lot higher security. So I think of culture as the fundamental to be able to do technical work at all in a high quality fashion. And then you get to be able to do all those technical stuff that gives security. But technical excellence without culture is not possible. And cultural excellence without any technical knowledge at all will not yield security.
So it's a both and.
Yes.
It's definitely both ends.
Great. Well, thank you very much. I think it's been a great conversation. For SE Radio, this is Sam Taggart. Thanks for joining us.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.